Thanks everybody for joining. Let's go ahead and get things started. Thank you for joining this session. I'm really looking forward. This is an extremely interesting topic for me especially. So today we're going to have a session with Chris Dearden from Komprise. My name is Lee Razzo. I'm the CEO and Chief Technologist of Cloud Native X. What is Cloud Native X? Very briefly, Cloud Native X is a one-stop shop for all things cloud native. So there'll be a lot of developments in the coming weeks and months. We will be posting a lot of original content. We'll be hosting sessions just like this one, webinars, tech talks, different sorts of topics. So I encourage everybody to go to the website, cloudnativex.io, subscribe to the newsletter, which will be once a month at the most, to give you updates on events in the future, such as this. And besides hosting events like this, we'll be covering all kinds of topics in the cloud native space, such as API security, among other things, AI ops, which was a session we had yesterday, and topics like today, data management in the cloud. And in this particular session, we're going to talk about the topic of data sprawl. So with that, I will kick it off and hand it over to Chris. Chris, tell us, what is data sprawl and how can we manage that?
Thanks, Lee. Yeah, so hopefully over the next 10 minutes, 10, 15 minutes, we'll be able to understand a bit about what is data sprawl, what causes it, and perhaps some of the things you can do about it. So let me share my application.
And while Chris is doing that, there is a Q&A tab. If you have any questions, I'll be keeping an eye on that. Feel free to type them in there.
Sorry, I shared the wrong application. Let's try again. Here we go. Can you see that's okay?
Yep, looks good.
Fantastic. So yeah, apologies for my drawing skills. I only got as far as GCSE, which is sort of middle school for the international people in art, but I'll do my best. Data sprawl is the growth of data, and in this particular instance, we'll be talking about unstructured data. Whichever analyst you prefer, they all have some equally scary numbers, but the one that we tend to look at is that data is doubling about every 2.5 years, and that's a data growth rate of around sort of 42%. And not only is that potentially causing operational pressure, it's going to be causing some financial pressure as well on enterprises. And one of the main reasons for this is that we're deleting less data, and we're deleting less data because we're data hoarders. We're kind of like this guy here. Data hoarders, they don't always organize their data particularly well, and they never really throw any data away because they never know when they're going to need something. And let's face it, we're all a little bit of a data hoarder. To give you an example, I was looking at my phone and the gallery on my phone the other day, and I noticed I have an unusually large amount of pictures of my solar electric meter. And this is because it's in the corner of my garage. I had to take a photo of it to be able to read it. So I take my reading, I submit it, and I never delete the photo. And I have this whole album now of pictures of my electricity meter. So I have finally got around to deleting those, but it's just one small example of how people just keep data that they forget to delete. But it's not always that they forget to delete the data. The culture of not deleting data can often start with things like regulatory compliance. When you look at certain industries that are mandated to keep data for 10 years, things like insurance, they have to keep data for even longer. But those regulations don't stipulate that the data has to be kept online on your most expensive storage for all of that time. It just needs to be accessible. So the culture of perhaps being able to move that data somewhere where it's going to be effective, it's the right place for that data is quite important. But the value of legacy data isn't just in regulatory compliance in that governance space. Businesses have realized that you can start to mine some of that data and discover and develop some trend analysis of it. So in order to be able to do that, you have to keep the data and it has to be accessible at that point. So you need to be able to get at it. So there's no use having it on a tape that's sitting in a secure bunker down the road, because you can't read it. It's effectively gone until you have to spend a lot of time and energy recalling it. But you also have the data that we would start to describe as rot. And this is data that is redundant, obsolete, or trivial. And that doesn't really come under any of those particular types. The redundant data is just where you've had multiple copies. Obsolete data is data that is out of date, not really serving any purpose anymore. Maybe it's been superseded by more recent data. And trivial data that just should never have been there in the first place, whether it's people's own data, whether it's the menu from the office Christmas party 4 years ago. It's data that really shouldn't be sitting on enterprise grade storage. But the other reason that our data requirements are growing is that data has become more rich. Just take media for an example. We start off with 800 by 600 resolution videos, and that went up through HD and then 4K and now 8K videos. So as that quality of data improves, the space it takes up gets better. Taking an example from another industry, with genomics, we've actually got a customer that is doing some sequencing, and every time they release an update in their software, it creates 4 times more data for the same run. And that means that their storage requirements they're absolutely going through the roof, and there's no way that their budget can keep up with that, because the problem is always going to be compounded. For every terabyte that you want to store, so you got to have that capacity for it. I'll try and spell right. You need to have the capacity for it. It's got to be fast. You've got to have the performance to be able to provide users with what they need to be able to access and analyze that data. And it needs to be available. So for that terabyte of data, you might be replicating it to another node in a local cluster. You might be replicating it to another site for some geo-redundancy. You're almost certainly going to be backing it up. So now for that 1 terabyte that you need of usable data, you're purchasing multiple terabytes of data. And things like dedupe and some of the other NAS technologies are really helping with this, and they actually also help with this. They help with the redundant part of the data rot, because they're going to reduce those duplicates through native deduplication, and that's very much table stakes for a NAS. But still, the growth is there, and you end up in this cycle of having to catch up to maybe provision some space, and you over provision. You buy much more than you need, which means you're buying it at today's prices. And even if storage is getting cheaper per terabyte, because you've had to buy 5 years worth of storage at a time, you're not going to take advantage of that, of the future drop in prices. So there potentially needs to be a bit of a way to break this cycle. And how can we do that? And I think that one of the really key things is understanding your data. And a question that I ask a lot of storage admins that I speak to is, what does your data look like? How active is it? And the most common answer I get is that they don't know. And there's no shame in this. End users and applications can be sometimes a bit chaotic. Although I do have, I've yet to beat the person that used their recycle bin as their main mail folder. But that's the extremes of chaos. You can't always control how users act and how applications act. So you need to make use of a tool set to do it. And there's a number of different approaches that you can take. And there are some tools that are really, really specific. They're what I would kind of call a laser focus. They will look at a subset of data, and they can open up the files, and they can look through the content of those files and maybe look for personally identifiable information, credit card information, poor language, whatever you want to do. And they're great for getting that bit of information and very specific data governance, maybe for sort of, customer services type people. But to get that wider picture, you need something that's going to be inherently more scalable. And that scalability is going to come from looking at the metadata. And the file system metadata that we've got, whether it's sitting on SMB, whether it's sitting on NFS, whether it's even in an object store, can actually tell us a surprisingly large amount about the data. So aside from just the name of a file, the extension is going to tell us something about the type of data it is. The size, obviously, pretty key. If you're trying to reduce your capacity, then looking at the size of the files is very important. But also things like the access time. So how recently was it touched? Not how recently was it changed, but how recently did someone actually open and look at that file? And as you start to collect this data, and you can collect this data pretty quickly because it's quite lightweight, you're not having to open up the files, you can discover a little bit about it. And one of the interesting things that we see is that data is often much colder than we think. And for a typical customer, we see something like 60 to 70% of that data hasn't been touched in 12 months. Which is, a pretty long time. And if it's not been touched in 12 months, is there somewhere that you can put it that is going to be more cost effective, that you can bring it back to your primary storage if you need it, but it doesn't have to live on your top tier of storage? So bear with me 1 second. If we were to collect all of that data, and we can present it in a way that allows us to make a few insights around it. And that's exactly what we do at Komprise. So this is what we'd call the aggregate analysis. And the focus of that analysis is this. This is the data donut. And it's a graph showing us the capacity by access time. As you can see, the colder the data, the bluer the color. And as we get to our hot data, then we have the hot side of the graph here. And this switch over is at 12 months. And this is a pretty accurate representation for a lot of customers. But we can also view some of the data. We can break that down by its file type, and we can break it down by its file size. We can also break it down by things like the owner and the actual subfolder. And this can give us a pretty good high-level view of what the impact of applying a policy that says, what, if that data is older than 12 months, let's put it onto some cheaper storage. That impact is not going to be just, saving you up some storage, but it could relate to some cost savings as well. Now, no storage provider is ever going to give you some money back because you're consuming less of it, but you might well be able to avoid that next upgrade. You don't have to go and automatically buy a disk shelf every year. It's not the storage admin's birthday present. So there's a cost avoidance that you can start to show and start to build up a bit of a business case. But if you want to go a little bit deeper into this, you can start to build up perhaps an index of every file that's crawled. And in this particular example, I'm looking at about 6 million files. But what if I had 60 million files or 100 million files? It would be nice to know a bit more about those. And if they were sitting across multiple platforms, that's going to be something that's quite hard to be able to look at, just with conventional tools. So we have the deep analytics view. And deep analytics, as I said, it builds up an index. That index contains a record for every file that we've crawled. And within that record is that file system metadata, that size, the file extension, the access time, the owners. And we can actually start to see exactly which files are making up these various bits of the hot and cold data. And this is where you can discover some surprisingly interesting things about your data, whether it's a database file, a database backup that has been left in a personal drive, SQL DBAs love to take extra backups, and they generally forget to delete them. Or what if it's someone's exercise videos? And this is a real example of doing one of these assessments, and you've found a bunch of the P90X videos that were 3 years old, hadn't been open for a while. Someone had clearly downloaded them, dumped them on there. That's not really the sort of data that you need to be considering. Doesn't need to be backed up. Most definitely shouldn't be migrated to your next storage platform, whether that's going into Office 365 or to a brand new shiny NAS. So that's data that's very easy to identify that you can just get rid of it. And that's really the trivial part of that rot data. And it's really quite simple how you're able to identify and start to build up some of these savings just by having a look at the file system metadata. So just to sort of sum things up, really, knowledge is power when it comes to taking control of your data. And if you can make use of a solution of something like Komprise, you can build up that picture of what your data really looks like, and manage that ever-growing estate of unstructured data. This is just the first in these series, hoping to do a few more of them, where we're going to talk a bit about the actually taking some of these insights and putting them into action. What can we actually do with that data? How can we, now we've identified the data that can live elsewhere, how do we actually do that?
This is great, Chris. A really great session. Thanks for that. I have a couple questions myself, actually, on this. One of the things you mentioned, which most of us are familiar with, is things like the rot. I like that concept. Redundant data, outdated data, obsolete, trivial data. But now what we have is the complexity of even like multiple clouds and multiple protocols. They have S3 and NAS and Block and Azure and AWS. How does Komprise work with all those different standards and protocols?
So our observers can they can effectively talk to the unstructured data independently of protocol. So they'll mount an SMB share, they'll connect to a NFS export. We have our cloud product, which can talk directly to those object storage buckets, because at one point, cloud was seen as the answer for everything for storage. Just put it all in cloud, and you suddenly start to get the sprawl of object storage buckets in the same way that you're getting sprawl of NAS data. So being able to analyze that, again, you can see the direct impact. And unlike an on-prem experience, you are going to save some money if you can get rid of some of the data, because you're charged by the gigabyte or terabyte of data that you're storing with these public cloud providers. So making sure that the right data's in there, that you're not having to pay extreme amounts of egress because you're pulling data that's really frequently accessed from your cloud provider, is all part of building up that picture.
That's great. So it's basically giving a little bit of independence. The data gravity of a cloud provider or of a certain protocol. This gives you a little bit of let's say, an insurance policy, I guess.
Absolutely. If people do have questions that maybe pop up afterwards, please do contact me. My email address is chris.dearden@komprise.com, or you can find me on Twitter at Chris Dearden. Nice and easy to remember.
Yeah, fantastic. Thanks a lot, Chris. And yes, please follow up with any questions. We will be doing follow-ups to this. So stay in touch. We'll be announcing these on the newsletter, and Chris and Komprise will also be announcing these as well. So thanks very much for joining, and hope to see you on the next one.